welcome everybody to the final Glow Your Own workshop of the Revival series. Today we're going to explore how we can incorporate a servo motor into our Arduino boards and our sculptures that we've made. CJ is going to do a short demonstration of the physical setup, followed by Sophie going through the practical side on Tinkercad. So all you're going to need for this session is your Tinkercad name, nickname and password. And as always, the session is going to be recorded and posted online. So if you have any comments or queries during the session, pop them into the chat box and our brilliant Glow Your Own team will be ready to help you out and with a response on the chat. So I'll pass over to our wonderful leaders for the day.
I think I'm up first, aren't I, Sophie? Yep. Okay. Thanks, Bernie. Okay, so I'm going to take this down now, because the screen down, so you can see what I'm doing. I'm going to get just a quick demo of how to connect the servo motor up to our Arduino board and breadboard. So first steps are to get your breadboard, and we need two wires, one red wire that's going to power, so it's in the plus side of the strip, and then we've got a ground wire that's going from the minus side. So we need two wires for that, and we need again the same colors ideally if you can, and so we've got a power one and a ground wire again there. So we've got 4 wires here, 2 power ones and 2 ground ones. Okay, and now we've got our servo motor here, and we're going to get another color of your choice wire and connect that to the orange wire, or it's usually an orange wire on this servo. That's the wire that will actually be connected to the pin on the Arduino board when we get there. And then we've got a power wire, it's the red one in the middle, and then a ground wire, it's the brown one in this case. So what we need to do with the wires, so we ignore these for now because they're going into the Arduino board, these two, but we're going to take the other power wire here from the breadboard and place it into the middle socket of our servo. That's the wire so we take our red wire power one, connect it to the middle red power wire on the servo, and then we get our ground wire that's next to that wire that if you can see that, yeah, and pop that into the ground socket. So now we have fully connected our servo motor. It's quite a simple setup. The code can be a bit more tricky, but the setup's pretty simple. And coming back to our wires that haven't got anything on the other ends, we're going to connect our ground wire to the ground pin on the Arduino board. So it's going in there. And then the other one is the power one, so the one on the plus side of the strip, into our 5 volts socket on the Arduino board. And then our final remaining colored wire of our choice, the one we picked for our pin, that is going to go doing it onto pin 9. I mean, some of you may have got something in pin 9, but in terms of the code that I've got, I've wired up to pin 9, so we'll pop that into pin 9. It's got that on this Arduino board. Okay, so that's the setup of the servo, and I've used a blank breadboard here just to make it easier for you to see, but the code has been integrated with the touch button that we used. Haven't integrated the code with the LEDs yet because that takes a little more probably explaining and showing, but I've got the straight up the button that goes with the servo this time, and it can be integrated with the LEDs, but the code is slightly that bit more tricky, and I'd probably need to go through that with you in a different way. But it's building on the same board that we have, so you can use all of the same setup that you have with your touch button, and instead of it lighting up the LEDs, it's lighting up it's making the servo move. So I'm going to do a little like magic trick just now. 1 second. I have to switch around my, okay, so that's that, yeah, okay. So I have the final product, which I just made a hand that is hopefully going to move, and the intention was, the concept was that it can touch a plant and make the plant move. So, and the way I did this, I fixed the servo to just a piece of cardboard, stuck it down. This can be a bit fiddly, and then I stuck the top bit of the hand down as well with some masking tape, so it's relatively secure. Can you still see? Yeah. Okay. Right. Need to, and then we should have a moving hand now. It's not the fastest because of the power that goes through the circuit, but it's sort of visible. So you can turn it in different ways to like interact with the object or the plant or whatever. But yeah, very, very basic, but still cool, and getting the servo moving. And you can do whatever you want, really. Right, so now we're gonna hope that, so if you want to kind of come back to this, look at the little setup in your own time, that's great. And now we're going to go to Sophie to do the fantastic Tinkercad example of the servo.
That is so cool. Sorry, everyone. That's the first time I'd seen the hand as well. And I just want to watch the hand moving around.
I just decorated it with nature things.
Oh, it's brilliant. I love it so much.
Cool. Thank you.
Thank you, CJ. Okay, everybody. So what we're going to do for the rest of the session is to figure out how we can code that to get that moving hand, like CJ was just demonstrating to us. So in the chat, you will see the link to Tinkercad, to the Tinkercad class. So do click on that. And while you're doing that, I will share my screen and we will work through the coding together, if that's okay. So you'll remember that when you go into Tinkercad, you create a new circuit. And then once you've created a new circuit, you come up with a picture or a screen that looks a bit like this. This is our blank one, and I've already named mine servo motor, GYO, for Glow Your Own. I should have named it something like cool hand thing, but I didn't. All right, so the first thing we're going to do is just create an electronic version of the circuit that CJ showed us how to do in person, in real life. So as normal, our first two components that we're going to grab are our Arduino. So you can look at the components on the right-hand side, pull the component that you want out, and just leave it in this area over here. So you want an Arduino and you want a breadboard over here. Now, it doesn't matter where you orient these, but I did spend quite a lot of time figuring out where I could put them so I didn't have to cross my wires, so they all look nice and neat, which appeals to me. But if you don't mind having wires crossing over, it doesn't make any difference. So once you've got these two, the last component that you need apart from wires is our servo motor. So you can find the servo motor on this basic components. If you go all the way down, you'll see this one that says micro server over here. It looks a little bit like the top of a helicopter. Not a very successful helicopter, but so you just pull that over and pop it over here. And the servo motor is just a specific kind of motor. Normally, they only turn 180 degrees, so they only turn around half a circle. And they've got 3 different connectors like CJ showed you earlier. And the really nice thing about Tinkercad is if you hover over each of the different connectors, each of the different little holes that you can connect to, it tells you, Tinkercad tells you what you're supposed to be connecting to. So this middle one, you'll connect to power. This one on the left connects to ground, and this one on the far side connects to the signal. Okay, so I'm just going to make you a little bit bigger so I can see you all. Everyone up to this point? Yeah, we're all okay? Fab. Okay, so now we just have to make a complete circuit that connects the Arduino to the servo motor and make sure it all goes round in a complete circuit. So to start with, we will start by connecting the power on the servo motor to our power rail on our breadboard over here. So you'll remember that to create a wire, you just need to click where you want to start, and then you can click around to here, to this. And then if you're like me and everything has to be straight, you'll rearrange your wire slightly so it's all right angles. So you can see that this wire goes from the middle one of the servo motor to the bottom line of my breadboard, to the red line here. And like CJ showed you, I'm going to change my color of my wire to red because it's coming to the power. You don't have to do that, obviously. It doesn't make any difference. It just makes it easier for you to spot bugs, and it looks prettier as well. Both of which are very important. So that's our first wire, and our second wire, we're going to connect our servo motor to our ground line on the breadboard. So that's the row of pins next to the minus sign down here. So I'm going to create another wire that goes like this. It goes all the way up to the minus sign here, to the minus line here. And like CJ said, I'm going to change the color of my wire to brown because it's going to the earth. Okay. All right, now I need to connect the Arduino. Sorry, I didn't mean to move that around. I need to connect the Arduino to the power and to the ground as well. So firstly, we're going to connect the ground, and you can see, you'll remember that down at the bottom, you've got the labels for the pin. Would it be helpful if I zoom in a bit, actually? For this, so you can see the different labels. So you've got this ground pin here. So I'm going to connect, like this. I'm going to connect my ground. I'm going to come all the way around up here and then connect it to the ground line. So it's connected through the breadboard to the servo motor. And then again, I'm just going to make it neat because I like things being neat. Okay, and then next we've got to connect our power line on the breadboard to the power on the Arduino. So you can see the one that says 5 volts down here, 5V. I'm going to connect that all the way like this and turn it into a red wire again. Now I know I'm going through this quite fast. If you're not quite keeping up, don't worry, because you can look at the video afterwards. There's also a diagram in the document that Emily sent you, and CJ's already gone through the connections. So this is sort of just repeating it for you. There. Making everything nice and neat. So the final thing we need to do is connect the signal. So this is what tells, this is where the servo motor receives its instructions from the Arduino. And so it says, the Arduino will send an instruction saying, turn this number of degrees. So I'm going to connect this signal line straight to one of the pins on the Arduino, and I'm going to go to pin 2, like this. And I'm going to choose a yellow wire for my signal here, like that. All right, and then we've got our complete circuit. So we go from ground on the Arduino up to the breadboard, all the way along to ground on the servo motor, and then to the power line here, and then down to power in the Arduino. So we've got our nice complete circuit that we can code away and send our instructions to the servo motor. So servo motors are used a lot where I work at my lab, because they're really quite good at moving things to a particular position. So often we've got to, I don't know, hold a mirror at a certain angle, or the laser will burn holes, burn scorch marks on the wall. Not that we've ever done that with our lasers. There definitely aren't scorch marks on the walls of our big powerful lasers. But so we have to be sure that things are in exactly the right position, and servo motors are really good at that. So we are now going to code our wonderful circuit. So if you click on the code button over here, the toggle code up at the top right, then we get our all of our different coding options. Now, this is just the standard bit that comes up, so we don't want that. We can delete all of that. And what we want to do is, I want the servo motor just to move in fixed increments. So move 10 degrees every second or something, or every half a second. So to start with, we are going to make our lives a little bit easier by creating a couple of variables. And variables are just, I'm sure you remember, they're just numbers or things that the computer remembers. So you say, computer, remember that the angle is 10, and the computer will remember that the angle is 10. And so you can use that again and again. So I'm going to create two variables, and you can do that by clicking on the one that says variables, the pink one, and then create variable. The first variable is going to be called angle, and that's going to be the angle of the servo motor, so the angle that we want it to move to. You can name variables whatever you want, but it's sensible to name them something that's related to the thing that you're using, because otherwise you look back at your code 3 days later and you've got no idea what variable A72 means. So we want one angle, one variable that's called angle. I'm going to create another variable that I'm going to call change. And this is the amount that I want the angle to change every time, every certain number of seconds. Okay. And we're going to start just by telling the computer what number we're going to start at. So the angle is going to be 0 to start with. So the position that the servo motor is in now, no degrees, and then and then I want to set the variable change to a different number. So I'm going to change this variable to change. So I've got set angle to 0, and then set change, and I'm going to change that to 15 degrees. Okay. All right, so now the computer knows where we are starting, and what we want to do is I want to have a loop. So it changes the angle every certain number of seconds. Right, and you'll remember that we can have loops in this control section, this repeat thing here. So we're going to use a repeat while block here, and I want it to repeat forever. And so I'm going to use some maths to tell it to repeat forever. So I can go to maths, and then I can get this pointy one here. So I'm going to say repeat while 1 equals 1. You pop that in there, and then you just have to remember to change this to the equal sign, like that. So this is going to mean everything inside this block, as long as 1 equals 1, everything in the side of this block is going to keep going over and over and over again. All right, we all okay? All right, and what we want to do is we are going to change the angle. Every time we go through this loop, I want to change the angle of the servo motor by this number of degrees, by change degrees. So you can do that very handily using these things in the variables button, in the variables set of commands. So you can use change variable, this one called change. So you want to change this angle, but I don't want to change it by 0. I want to change it by this number called change. So every time it's just going to say, the computer's going to change what it knows is by this number. angle. And then we want the servo motor to move to that position. And Tinkercad has very nicely given us a command that does that. So if you look at output, so things that it tells the Arduino to do, you will find this command that says rotate servo. That just means it's lazy and couldn't be bothered to write the word motor as well. So you could put this rotate servo on pin, and our servo is connected to pin 2. So we change that to pin 2 like that. And we want to change it to the number of degrees that is angle, our variable called angle. So we go back to variables, we choose our variable angle, and we pop that in here like that. Okay, and then just so that we can see it moving, we can see it working, I'm going to wait, I'm going to pause every half a second. And so it's going to move 15 degrees and then another 15 degrees and then another 15 degrees. So you'll remember that you can tell the Arduino to wait by going to control, and then you've got this wait a certain number of seconds. So I'm going to pop wait in there, and I'm going to say wait half wait half a second. Okay, and that is our code. It's really quite straightforward to do this first step here. So once we've written our code, the next thing is to simulate it to see if it is working and if we've done everything right. And you'll remember that we start our simulation. I'm just going to make this slightly smaller so that we can see it like this. So start simulation. And if we've coded this right, if I've coded this right, we should see our servo motor start to move around. So cross your fingers and click start simulation. It's thinking about it, and then you can see it's moving, which is fantastic. We could do it again. Dana's clapping, so I assume that means his worked, which is fab.
Yes.
Great. Oh, and Kathy's is working too. Is everybody's working? Fab. Bernie's is as well. Brilliant. I hope everyone's is working. But you'll see that. So I only let it go for a small amount of time. So if I just leave it running, you'll see it turns, it's doing great. We're brilliant. Look at us getting our servo motors to work. But then it just stops, which isn't as exciting. And so what's happening is that servo motors tend to only go around half the time. Oh, sorry. I don't know what I did then. And so it gets up to this point and then it can't turn anymore. So it just keeps carrying on and trying. And we can see what number, we can learn what number it thinks it's turning to by using this really helpful command called here, print to serial monitor, which is the most useful thing if you're ever debugging, if you're ever finding mistakes in your code. So what we're going to do is we're going to put print to serial monitor inside this loop. But instead of printing this thing saying hello world, we're going to print the variable angle. So just so that we know what that number is. So we can go here and then we can print this angle here and pop it in like that. And you'll see at the bottom here, there is a thing called serial monitor. And if you click on that, it comes up with some, with a bit, sorry, Dane, did you say something?
Oh, sorry, I forgot. No, it's working.
Okay, good. I'm glad it's working. You'll see this thing coming up here. And then when we press start simulation, the motor moves, but you can see the angle that it's printing down here. And now the servo isn't moving, but you can see that the angle is changing. So what we want to do, oh, sorry, I pressed the wrong button. I meant to say stop simulation and I pressed stop share instead. Hang on a second. There we go. At least I didn't press leave. On Teams, when you're sharing, leave is right next to the button that says stop share. Very, very worrying. Okay, so
I've got mine spinning round, but it's now just going round at slightly small increments, but it's still continuing.
Yeah, mine is too.
wow, I don't know why.
That
That's very
happens.
exciting.
That happens in physical setup as well. I don't know if it's random power that's just going to it, but it's not actually computing something. It does happen to me at rest, even when I haven't coded. Something with the power.
Ooh,
I've copied
That's
you
exciting.
completely, Sophie, and
You have.
it's not doing what yours is doing.
well,
Yeah,
that's
mine's
always
going round
exciting.
and round and round really slowly.
Ooh,
Mm.
that's very exciting. I don't know why. See, this is the wonderful thing about coding
Yeah.
and engineering. Sometimes you think you're doing exactly the same thing, and the computer goes, "No, I think that's a different thing." Probably because of some setup that we've got differently somewhere. That's exciting. Maybe we should have a look, or maybe. So I can change, why don't we do it so that I will show you how I get it to move backwards and forwards and then backwards and forwards and then backwards and forwards, because that's a nice little bit of coding using if loops, which are really, really important, very, really useful. And then we'll see what Kathy and Danes is doing and why it doesn't do the same thing that mine is doing.
Although it has now stopped, now I've vocalized the issue.
And mine has stopped as well now.
Okay, let's move on.
Okay.
Sorry for the interruption.
No, it's brilliant. I love that it's doing strange things. Really, seriously, whenever we're coding, I spend more time debugging than coding, trying to figure out why it's doing it. So yeah, this printer serial monitor is really helpful, everyone. You can do it with physical Arduinos as well. And the instructions that Emily sent around just remind you how you can do that in a real one. So what we're going to add to this is just a little if statement. So what I want it to do, instead of going around halfway and then just stopping, I want it to go around halfway and then to change direction and go back to where it started, and then forwards and backwards and forwards and backwards and forwards and backwards forever and ever. So we're going to use an if loop, an if block to do that. So you can go into control here and find this one that says if. And ifs are really helpful because it basically just asks the computer a question. Is something true or is it not true? And if it is true, then it does a certain thing. It will do whatever's in this loop. And if it's not true, it won't do whatever's in that. So what question we want to ask is if is the angle, this value, this variable angle, is that greater than or equal to 180, so halfway around? And if it is, then I want to change the direction that it's moving, that the servo motor is moving. So we can go to maths here and get a one of these, a conditional, we call them. And we want to say if the angle, remember that's in variables, if angle is greater than or equal to 180. So that's this little arrow with a line under it. You can see here, greater than or equal to 180, halfway around. Okay, you can see that. And if that's true, then I want to, instead of change the angle by 15 degrees, I want to change the angle by minus 15 degrees. Okay, and we'll see what happens then. So we can change the variable change. So we set our variable change to minus whatever the variable was to start with. So we can do a little bit of maths here to get that minus times our variable. Pop that in here. So instead of setting change to change plus 1, we want to set change the change multiplied by -1. Okay, so if the angle ever gets beyond that, then it will do whatever's in this little loop here, and it will set change to -15 in this case rather than +15. All right, does that make sense, everyone? Fab.
Set change.
Kathy looks like she's doing
Right,
it, so I'm
just,
going to wait
just
for a minute.
working out whether I'm writing change or angle. Set change
Yeah.
to change.
Change. Yeah. So what we want to do is we want to take whatever number we we're in the we're changing the angle by, and we want to, instead of doing it plus, which would move it to the in an anti-clockwise fashion. Sorry, clockwise, left and right, they're really difficult. And we want to change it to a minus number, which would change it into a clockwise direction. Yeah, okay.
Oh, things are dropping into the wrong sections for me.
You've got to be really careful. You can pick them back out though.
Yeah,
You
I've
can
been
just
doing
pull
that.
them back out.
It messes it all up, but
Yeah, like that.
Pick them back out and do it again. Yeah.
It is quite tricky sometimes. I have to concentrate on where things are going. Okay.
it keeps doing it.
But remember, there's always the online video, so let's be kind to ourselves here.
Oh, absolutely. Always be kind to yourselves. And like I said, we spend much more time fixing the problems than we do actually writing the code. That's the fun bit. We have celebrations when we find a new problem. It's like, well, it's still not working, but now it's telling me a different error message. That's progress. All right.
That's science in one go, isn't it? There sometimes. Just
Pretty
a different
much.
problem.
Yeah, we've got a different problem now. All right, so I'm going to start simulating this and we will see what happens. So what should happen is it should go all the way to this point and then start moving backwards. So thinking about it, it's moving around anti-clockwise. You'll see it's getting down to 120. It got to 180 and then it started going in the other direction, which is fab. But then it stopped which is brilliant. So it's what we wanted, but now it's saying the angle is like minus 180 or something. So we want it to turn back the other way once we get to that point. And we can do that. So here we've just got one condition, but we can use some lovely logic, which is in our maths thing. And we can use this, which is called Boolean logic. I don't actually know why. Sarah, is that named after like a Mr. Boole or something? Anyway,
I will Google it.
Oh, thank you, Sarah. It's called Boolean logic, and it asks us if a couple of it asks about more than one condition. So I want to say to change the distance it moves by if it's more than 180 degrees, or if it's less than 0 degrees. So our first condition, so I want to use an or here. So you can change this from and to or. And I've put it up at the top just for now to make life a little bit easier. And then I take this first condition that we already know is working and pop it in one of the triangles like that. Now we have to do another one for the 0. So we again go back to this maths and we use this one the same as we did before and pop it in there like that. We want to use our variable angle because we want it to do this if loop if the angle is less than 0. We pop angle in here, and then we've got less than or equal to, so that's the less than with the line underneath it, 0. So I'm just going to zoom in on that bit a little bit, so because I know it's a bit hard to see. So you've got less than or equal to here, 0. And then we move down like this. And we pop that whole thing, all of these both conditions into that. So what should happen now, what we want to happen is it will, I'm going to stop moving my Arduino around somehow. The servo motor will move around, then it will get to an angle of 180 degrees. It'll go, oh wait, my angle is 180 degrees. So it'll change, our value change to -15 here, because it will multiply by -1. Move backwards until it gets to the angle is 0. And then it'll go, oh wait, my angle's 0. I need to multiply by -1 again. So my change will be +15. All right, let's see if it works. Right, so it's moving around. It's working so far. You can look at the angle here, got this up to 180 and then back down. Now it went to, it's going to 0 and it's going straight back the other way. And now this should carry on forever and ever and ever. So we would have an internally moving hand. So yeah, now it is all working perfectly, or at least mine is, and hopefully Dane and Kathy's is too. Well, hopefully everybody's is, not just Dane and Kathy's, but theirs was doing something weird.
It's on its first go, it's turned back, it's turned back, it's on its second lap. It's like the Olympics.
Yay.
Oh, it's turned back again. It's going it. Yeah. Oh, it's turned. Yeah, it's doing it now. Yeah, backwards and forwards, backwards and forwards. It's like the marathon race in the Olympics, just going on and on.
On and on. Honestly, I can't. I'm not very good at watching sport. Everyone, I did turn it on and turned it off before I got bored in the 100 meters, and that's only 10 seconds. Well, there was, you know, they started running and then they stopped, and I didn't understand, so it was too much for me. Too much for me. So yeah, now we have our beautiful servo motor that is working, that we could use to move our hand to touch the plant. You can move it to whatever angle you want. So we often use it to, like I said, to move our lenses or our mirrors. You can link it up to sensors, so it will, and the angle that it moves to will be dependent on the sensor. So for instance, you might remember that some of the rovers on Mars, some of the robots on Mars have solar panels to generate power. You can move the angle of the solar panel so that it catches the most sun by hooking a servo motor up with a light dependent resistor. So the light dependent resistor will tell you where the brightest light is, and then that will say, okay, so my solar panel should be pointing towards the brightest light so I can generate the most power. So they're really, really useful little things for us in science, and we can use them for make all kinds of beautiful art like CJ showed us earlier today. And that's how you use servo motors. And either we went really quickly or you're all really good. I'm sorry if we went too quickly for people.
I managed to just about keep up. Sarah, Sophie, sorry, if you could just move your Tinkercad coding a fraction, your magnification screen is obscuring one of the, just move it, just drag it up a fraction. Just drag,
sure,
that's it, yeah, perfect. Thank you.
Actually, I can make it bigger.
So that's what it should look like. And mine looks the same and is doing what it should do, which is brilliant.
Hooray. That is what we want. All the time. We want it to do what it should do, what we think it should do anyway. Computers are very good at doing what they're told, mostly. They're not very good at doing what you want them to do, but they are good at doing what they're told.
I'm just going to pop into the chat the link for the GitHub that we usually put the copy and paste the code for the physical, just so you've got that as well, just in case. I've put that link in now. So that's if you want to refer to that and go through any of the physical setup and code. You can look through the code and see how it's in like working with the touch button that you have had in the past.
Oh. So does anyone have any questions, I guess? Is everybody's working on the simulated one? Bernie's looking very pleased with herself, which is fab. You should be.
Yeah, it's the first time I've got Tinkercad to work, so I'm really, really pleased.
That's what we want.
And everyone, I checked, Boolean logic is named after George Boole, who has an entire section of algebra named after him. So I'm going to do some more research after the session, find out what else he got up to.
Lots of cool. I mean, Boolean algebra is really, Boolean maths is really cool. But I just suddenly realized that I didn't know it was named after a person. Cool. Good for Mr. Boole.
Great. So hopefully when we do the Glow Your Own in October, we can incorporate some of this exciting practicing that we've been doing over the past few months to make a really interesting moving, flashing installation for our homes as we kind of move towards the darker months of the year. So this has been really, really good fun. I don't think we have any questions from other people. I think it's sort of working. I don't know if Kathy managed to make hers work. Bernie clearly did.
Yeah, mine's working perfectly.
So we've managed to achieve this, which is super good. So CJ, we're thinking about what we're going to be doing in the future. And we've got your great example of the waving hand, and we've seen our clouds that we've made from the previous session and what we can maybe make in the future. Have you thought of any exciting ideas, or is it still in the kind of
It is still in the kind of, what's the word? I don't know what word, but it's still undergoing. But I feel like I want to generally have something that lights up. So we're definitely having LEDs and a sound. This is in the external. Do you mean for the external, the one that's going to be in the community, or for their homes?
For the homes, we're going to yeah.
Yeah, no, it'll include all the servo, the LEDs, and the some sort of touch button. Yeah, but for there'll be the three elements that we're looking at.
That sounds exciting, and we've done a bit of that already, so we're familiar with how it works and how we can get it functioning. And it's great that new people to coding have had a go and managed to achieve this. So just to for those of you who might not know, so the Glow Your Own project and the Oxford Christmas Light Festival, which happens in November, are teaming up to find a way to make our imagination become even bigger. So the idea is, in the Glow Your Own sessions for the festival that start on the 12th of October, is that we'll make a project using CJ's creative development and Sophie's tinkering skills and Sarah's helpful kind of troubleshooting. And so we'll make something together as a team separately, so we can make something for our homes. And at the same time, we're going to see if we can make a bigger thing and maybe present that to the real world in November this year in a public venue, possibly in Blackbird Leys. And so there might be a way of exploring a different part of Oxford, and we might do a sort of live broadcast or something. I don't know how we're going to manage it, but it'd be really great to do something in a physical space that's outside. So hopefully it won't be raining, but if so, we'll have umbrellas. But the nice thing is to go, let's make something together on our computers, on our Arduinos, on our kitchen tables, or our desks or sofa, or wherever you're kind of coding from, to make something together separately. And then there could be a way of doing something bigger in person, so we can come to that and see what CJ and their tinkerers and their crafters have put together, to put together something that's a bit bigger and a bit flashier and a bit more interactive. But we'll see how that develops over time.
Well,
So
I think it's also going to have, just to add, it'll have some sort of well-being theme as well, because it's the darker months, as you said, Dane, and hopefully we can play on this idea of bringing light and an overall, well-being kind of theme throughout. So that's nice. Look forward.
really cool, and we can sort of celebrate our own crafting, coding as well. And there might be, I think we're probably finished off if there's no more questions. So we usually have a troubleshooting kind of extra bit at the end, and so unless anyone has any questions or any problems, we could
If anyone's got their sculptures from last time that they've maybe updated that they want to show off,
we can stop the recording if you don't want it going live.
Yeah,
share it to us.
So for the tape, goodbye. We'll see you next time.